Nice to meet you. Met someone yesterday, so it's good to see you again. My name is Chapman. I teach at school, so I am actually very young. But I'm still doing my degree. So if you're wondering how to become a teacher, you have to go to university to do a degree. So I did Bachelor of Education at UCIT right now. If you have any questions about uni, let me know. I also didn't know what I wanted to do back in when I was in your shoes, very long ago. So do ask me stuff if you want uni advice. Otherwise, yesterday, what did you learn? Div. Yeah. Most of you guys have learned div, right? Hands up if you learned div at school. Yeah, most of you guys. So it's just review. That's good. So if I ask you stuff, you should be able to get it. For example, Tanishi, what is maybe not, you already volunteered. How about that? What is first principles? Can you tell me bar for bar, word for word? The whole first principles formula.
F div x.
Yeah, F dash x.
F dash x. Limit h equals 0.
Yeah.
That means you're gonna sum it eventually.
Good.
And then you sum it f x plus h.
Yeah. Oops, sorry. Fx plus h. Good.
Yeah, fx plus h minus f of x over h.
Good.
And
Sorry.
then
Yeah. And then you just do it. Right. Now remember, Calvin told you 2 steps yesterday. The first step was write down your f of x plus h. Second step was write down your f of x and then plug it all in. And then solve it, and then eventually wait for the h's to do what? What do you want the h to do? To cancel, because right now I can't sub in h approaches 0. So that's the way to read it, but it doesn't really matter because I'm going to read out in the exam. But we say h approach 0. We can't sub it in because it's on the bottom. It's 0. Okay, cool. Now, remember, this was like some old German technique. Like ages ago they came up with this, but you have much faster ways to do it. So if I ask you to differentiate y equals x cubed, what rule do we use? What's the name of this? Power. Everyone knows power rule, yeah? 3x squared. Cool. Okay. Now, if I ask you the same thing, but now like, hey, it's like a little bit more inside, like that. What rule do I use here? Chain rule. Good. And remember, Calvin told you chain rule was just power rule and a little bit. What's that little bit? Just the thing on the inside. So the way I like to think about it is power rule, 3x squared plus 1 all squared times the little bit, that's the diff of the inside. So not just the inside bit, but the diff of that. Sounds good? Okay. What was the rule for differentiating something like this guy? X squared plus 1, 4. Product rule. Because you got 2 things multiplied together, right? What's product rule again?
V dash u plus u dash m.
Yeah, you know what's so interesting? You were with Michael yesterday, right?
A bit older than me.
Oh, Jerome.
We were with this guy that had a mustache.
Yeah, you're right.
Here's Jerome. Did he tell you much about himself?
No.
I tutored him last year. Just last year, yeah. And then I didn't like he just applied here. And then he became a tutor and I was like, dude, that's insane. So fun. Okay, but anyways, yeah, Jerome taught U dash V, V dash U. That's totally fine. That might be what you've seen at school. The ones in this room use what Calvin did, and I like doing what Calvin did. And it's for you guys who are new. It's a French word. It's voof. So if you ever forget it, y dash equals voof. Remember that French word, guys? So you write voof and then you dash the ends. And if that helps you remember it better, then there you go. You can also use the other way. Sounds good?
Yeah.
Knowing product rule is great because quotient rule is just, what is it, Mira? What's quotient rule?
VU minus UV over V squared.
Very good. So with quotient rule, quotient means fraction. So I always want you to write a fraction first, like this. It's just VOOF over V squared, very similar. But remember, it's VOOF and then you dash the ends. Good job, guys. All good? Sounds good? Okay, here's a funky one. Y equals x square root x. How would you differentiate this?
Index rules.
Good. Does this look like a product rule question though? Like, sort of. It's 2 things multiplied. But if you get a situation where 2 things are multiplied together, but you can just use index laws, you don't have to use product rule. And similarly, if this was x over root x, you don't have to use quotient rule. It's much faster to rewrite it like this. Now, I'm gonna make a silly mistake here. What have I done wrong then? What am I talking about? X root x. I just rewrote it using index laws. So x to the... Did you ask what I meant? What do you... Yeah. X to the 1 times x to the half. You know how this one, root x is x to the half? Yeah. And I added the indices. But what have I done wrong in my working out? What have I done wrong in my working out? Everyone always makes this mistake. It looks so fine, right? Did I bring the pound down correctly?
Yeah.
Did I lower the power by 1? So there must be something wrong in the setting out, not the actual maths. What is it? Avita? Good. So the mistake that people always make is you guys are going to get so good at differentiation. Not after this whole course. Remember, Calvin said you have to practice. But after a lot of practice, you're going to get so good. I promise you, it becomes automatic. The good thing about automatic is you don't have to think about it. The danger of it is you're going to just go too fast. And when you go too fast, you do stuff like this. You're like, why is this? And then you differentiate and you're like, it's still this. But do you see why like x to the half is not equal to that first line? Please make sure when you actually change it, you just write equals under the y. And then when you do differentiate, you do write y dash. Does that make sense? Any questions? Nope. All right. Last thing was the main thing we're going to start with today. And it was something that started with a T and an M. I don't remember what the special T word was. Tangent. What's a tangent? You can tell me.
The line that touches one cookie.
Yeah, good. It's a line that just touches a curve. It like just bounces off. What's the word that starts with M? Normal. What's that? Very good. So, if I have a curve, I'm gonna start with something easy. Tangents and normals. So like this and like that. A tangent would be something that just touches the curve, like so. So it just touches, and it shouldn't really cross that orange bit again. So it just touches like that. But in green here, this is what I call the normal. Like so, okay? And I can keep drawing that line. Now, what's the relationship between black and green right here? Perpendicular. When you have straight lines, and let's say I had the gradient of the tangent. What can you tell me about the gradient of the normal?
It's
Yeah, good. So remember, because these are 90 degrees, this is the one rule you're going to remember today. This is perpendicular to gradient n. When you have perpendicular gradients, when you multiply them, they're always going to equal -1. But I don't like remembering it like this. I like saying it like how you did. There are 2 English words that tell you exactly what to do every time you got perpendicular gradients. The first is, well, actually, let me rearrange this first. Gradient of normal equals -1 divided by gradient tangent. The first word is negative. The second word is, what did you say? Reciprocal. Good. Now, sometimes people use inverse for the word reciprocal, but as you guys, some of you guys have done extension 1, inverse is actually quite different. It's a whole other thing. So, yeah, let's call it negative reciprocal. All right. So that's what we're going to need for this first section. So let's go and dive straight into a question. Can you go to example 1 and you can fill it out in your little box there as I do it. Okay, so with example 1, we've got a curve y equals 3x squared minus 5x plus 2. And I want to find the tangent, equation of tangent at x equals 1. Because some of you have done this at school, I'll go through it quite quickly. Just one more hands up. Who's not done it at school? Thank you. Appreciate it. Okay, so what we're doing is we are always going to, step 1, we're going to differentiate the function. Okay? Differentiating the function is helpful. Because remember, is it working?
I don't think your mic's on.
Oh, my mic's on.
Okay, actually, I take my thing back. Step 1 is I'm going to ask you to find a point. Because do you see, in order to find the equation of a tangent, we eventually want to use something that helps us find equations of lines. I'm going to write this formula for you down. Actually, you tell me. Do you know what I'm trying to write here? Y minus y1 equals mx minus x1. What is this? What's this for again? What are we trying to do? Point gradient formula. So it means if you have a point, which we call x1, y1, and if you have a gradient, then you can find any equation of a line. Does that make sense? So when it comes to finding an equation, obviously you want to find a point and a gradient. So let's start with finding a point. It says I want the tangent at x equals 1 for this curve. So it's like I've got some parabola, and then they tell me at x equals 1, I want the tangent to that point. So obviously I need to find that point first. So what I'm going to do first is substitute x equals 1, okay? Let x equals 1. First, I'm going to sub it into the y. Quick maths, what's that? 0 minus 2 plus 2. Good job. Okay, when you sub it into y, what you're doing is you're finding the point. So I therefore know the point I'm working with is 1, 0. All right, here's the next thing I want you to do. Substitute it into y dash. Now, what does y dash tell you again? It's a gradient function, so it's a derivative, and it tells you how steep something is, okay? So when you sub in y dash, it's gonna look like this. 3 times 1, ooh. Before I substitute it in, actually go find y dash. So I'm gonna differentiate this. Guys, help me out. 3x squared differentiate, what's that? What's 5x differentiate? 5, awesome. Remember the x just drops off, you're just left with a constant. Now sub that in, so 6 times 1 minus 5. What this tells you is the gradient, so it's that m I'm looking for. Because later we're going to be dealing with different types of gradient, I'm going to specify that this is the gradient of the tangent, mt. Okay, in your working, I'd hope for you to keep working vertically until you don't have enough space. Now I want to substitute it into my point gradient formula. So y minus y1, mx minus x1. Well, I know y1 is the y value of our point. I wrote that here nice and neat, so I can just say that's 0. I know x1 is 1. And my gradient, m, is 1, x minus 1. Is everyone happy with that? Cool. All right, help me out conceptually, our steps. Because in maths, I want you to realize that maths is kind of like, you know, like biology and stuff, you use flashcards. Maths is low-key like a content subject. You can make little flashcards that tell your brain, every time I see an equation or tangent question, these are just the steps I have to do. And then when you get to a harder question that twisted it a little bit, because you have a scaffold in your head of what to do already, you can easily apply what you already know to those harder ones. So it's better if your brain has all these little like steps. So let's write some steps down. What's the first thing you would do when you're asked to find the equation of a tangent? Yeah, so multiple things you can try first. Let's go with that. Let's find a derivative which tells us the gradient. I know I always have to differentiate. So let's go find y dash. Step 2, I now need these guys, right? What do I need to plug into this equation? A point. So let's go find a point. I'm going to sub x equals blah, blah, blah into y. And what that gets you is a point, x1, y1. All right, 2 more steps. Obviously, if I've got a point, I now need to find a gradient. How do I find a gradient? Where do I sub that into? The derivative. So this one right now is y dash of x. It's a function of x right now. When I plug in the thing I want, I'll sub that into y dash, and I will get my derivative. So that would be the gradient of the tangent. I'll leave the final step off. As you know, it's just plugging it into the equation y minus y1 and x minus x1. I'll add a step to that later when we get to, in fact, our next question. Okay, so we have the graph y of x equals x squared minus 2x plus 3. But I want to find the equation of a normal in this case. Now, you know you're going to have to find a gradient. So step 1, just find a derivative because you're always going to need it. Okay? Look at the notation I've used. I've used y of x. It's kind of just like f of x. It's just a different letter. Are we okay with that notation? You'll see why I use it in a second. Now, when I differentiate, I'm just going to keep the x there as well. So y dash x is diff of x squared. Actually, let me pick on someone who's... Vincent, how do you differentiate this?
It's 2x minus 2.
Very good. Awesome. Awesome, awesome. Okay, now, I found the derivative. What I want to do now is substitute my x value into there. Or not into the derivative, but into somewhere to get a point, right? If you sub it in there, you get a gradient. If you sub it in this one, you get a point. So if step 2 is finding a point, I'm going to sub it in this one. So let's start with that. Okay, Now, here's the reason why I did y of x. So I just want you to look up really quickly for this one. Do you see I had to write when x equals 1, let x equals 1? Because I've used function notation, I can actually substitute it in without having to write any words. So I'm just that much lazier and I'm a little bit quicker. So then that will help you over your exam. Like if you're 5 seconds quicker for every question, and then there's like 100 marks. Now it's 5 times 100 seconds. And that saves you a lot of time just to even check at the end. Does that make sense? Okay, so here's my 5-second time saver. You're gonna do y of 1. That is the exact same as that. Do you guys agree with that? Do you see I just replace all the ones with x? Or x as ones? So y of 1, and then I go 1 squared minus 2 times 1 plus 3. 1 take away 2 minus 1 plus 3 is 2. All right, so I've got my point. It's a good habit to actually tell yourself what you found, because this is just a bunch of algebra right now. Be like, okay, I know that means I've got a x and y coordinate. Can someone tell me the point? 1, 2. Good. Okay. Step 3. Now, step 3 is sub it into the gradient function. So in the same way, I'm just going to do y dash of 1. That is the same as me going let x equals 1. But it's a bit clearer and quicker.
Why are we subbing in 1 if the question says x equals 3?
That's a great question. What you want to do, RTFQ, read the full question. Don't miss out. So this is x equals 3. It is x equals 3. I'm telling myself, read the full question. Let's put 3 there, my bad. 3 squared. Oh, just a few numbers. 9 take away 6 plus 3. Does that become 0 again? 6. Testing you guys. Y dash of 3. That's 2 times 3 minus 2, 4. Thank you. All right, where we at? Okay, so we got this. You guys are so sharp. This guy finds us the, what?
Gradient of tangent.
Gradient tangent. So mt equals 4. I would love you to write that. Okay. Last time we found the gradient, and we just plugged it into gradient, in point gradient formula, we got the equation. Now, mum soul, look up here. This is not what you need to do. Like, you need to do more. This question tells you to find the normal in general form, but the real thing here is the normal. And what this is the gradient of tangent. That's why I'm stressing you to write that, to remind yourself, this is not the thing I want. I want the gradient of the normal. I need the reciprocal. Okay, so in this case, if the question, you can add this to your steps. If the question was a normal question, you find this first, and then you go, wait a second, the gradient of the normal is equal to the two words, one's reciprocal, the other's negative. Awesome. Negative reciprocal of gradient tangent. So when you get to this line, this is sort of your pseudo step 4. Gradient of normal equals negative reciprocal. So negative 1 over 4. Okay? Now I've got all the things I need to plug in here. All of those ingredients. I just need a point and a gradient. So let's go plug it in. Now normally you'd make y the subject because you want it as mx plus b form. But in this case, you guys told me it was general form. What is general form? What is general form? Yes?
ax plus by plus c.
Very good. Now I want you to remember it like this. Everything to one side, because that will make it equal to 0. So everything to one side, because now it's like, okay, there's some left-hand side and it's equal to 0. Now the other thing I need you to make sure is that the coefficient of x is positive. Because we just want to make like one of them positive. I could have brought them all to this side or that side and that would flip that thing around. So let's try and do this carefully. I could expand, but what I can also do is get rid of this fraction by multiplying both sides by -4. Multiply both sides by -4. -4y plus 24 equals x minus 3. Okay, which side should I move everything to? Should I move all of this here, or should I bring this guy over here? This way, to the left, or to the right? I want to bring it to the right. What's the reason? Very good. If I move this over there, I've got negative x. I don't want that. I want to move everything to the other side so that x is positive. So you can think of it like this. 0 equals x plus 4y. Take away 24. There's already a -3 here. minus 27, okay?
You didn't expand it.
Oh, this line?
Like above it.
This one?
That one. Yeah, the negative 1 and 4x.
Yeah.
That you-
Yeah, so I could expand it and then I get negative x on 4 and then like plus 3 on 4. What I did, do you see what I did?
Oh, okay.
Yeah, so you actually get the same thing. Get rid of that fraction. Times both sides. All right, if you think this looks a bit weird, you can quickly switch it up. Or you didn't have to write 0 on the left side, you could have just had that. I would have been okay with you going straight to this. Guys, why do we box our answers at the end? Who are we doing it for? The marker. Do you guys know how markers mark? At HSC, they get paid per paper. So do you think they're trying to like take their time and help you? They're just trying to be fast, right? Because each paper, like it's their own time. Yes. So if you boxed it, no, seriously, if you boxed it and they're like, what the hell? I see the right answer. This looks roughly like perfect setting out. Like, I can see steps. I'm not looking into what they are. It's the right answer. Surely they got it right. Tick, tick, tick. If you make it really hard to read, then they have to go into and find it. Do you see they'll scrutinize all of your working out? You don't want that. Does that make sense? At school, it's similar. Like teachers just don't get paid to mark extra papers anyway, but we really value our time. So yeah, make it easy for your marker. All right. Okay. Just doing a name check. Kristen? Yeah. And behind Kristen is Simran. Yeah. Simran, can you help me out? What's the difference of a normal question? We had the tangent ones. When I say find the equation of normal, what's the one extra step you need to do? Very good. Now, I want you guys to do that. Like, some people get in a habit of thinking too early and they don't find the tangent. They just try to go straight to the normal. Just get this number first and flip it. That's all I need you to do. Okay. Beautiful, Simran. Thank you. Alrighty. Example 3. Now I want to find the horizontal tangents to this cubic. What are they asking us to do? What does horizontal mean? 0? What do you mean by that? What value? No, keep going. What do you think in 0? What do you think in 0? This is horizontal. The gradient of the tangent is 0. Awesome. I can't actually just say like the tangent 0 because the tangent is just an equation. So it'd be like a y and x thing. The gradient of the tangent should be 0, okay? So for example, in a parabola, like y equals x squared, when is y equals x minus 3 all squared. Do we have that in our brains? X minus 3 all squared. What value of x is the gradient, or is the tangent horizontal? Positive 3, because I just had a parabola that was shifted to the right by 3, and I'm asking for when that occurs, okay? So in this same question, here's what we're going to do. Translate the English to math. Whenever you see horizontal tangent, exactly like how, is it Tahini?
Tanishi.
Tanishi.
Yep.
I'm so sorry. Tahini is a great food though. My bad. I'm just big. All right, so whenever you see horizontal tangent, please translate that to the gradient of the tangent, mt. That's really horrible. I don't think you can read that. Just this line, mt equals 0, okay? So let's figure that out. Let's write that down first. If the gradient of tangent is 0, then what I need is the thing that gives me the gradient of tangent. Remember, that is just a derivative function, gradient function. So y dash of x is what I want to equal 0. Fair enough? Okay. Now we just need to find y dash. So we just differentiate this, all right? 2x cubed, differentiate, what do you get? Guys, everyone together.
6x squared.
Yeah, what's that one? 6x, differentiate minus 12. X, differentiate 1.
0.
Constants just drop off and they die, okay? This left-hand side is the derivative. That's equal to 0. Let's double check. 6x squared 6x. Nice. Okay. Yeah, that'd be weird, wouldn't it? So many x's. Okay. 6x squared plus 6x minus 12. Let's solve this. What's the first thing you do when you see a quadratic like this? Do you notice it's non-monic?
Yeah.
Yeah. But like non-monic requires different techniques to do, right?
Yeah.
You should do something first. Factorize what? Yes. So a lot of things are fake non-monics. They're just trying to make your life hard for no reason. This guy, I can see has a common factor of 6. So just factorize it out by 6 or divide both sides by 6. Yeah. Now, I know you guys are used to dividing both sides by stuff. When it's just a constant, that's good. However, if I gave you something like this, divide both sides by x, what do you get? Why is that bad? Why is it bad to do this? Kristen? Ooh, I'm trying to solve for solutions. So I do end up wanting like x equals numbers. And then when you graph them, they look like straight lines. But I'm not trying to interpret graphically.
It only gives one part of it.
One part of it? Nice. What's the part I'm missing?
You lose the solution, it's x goes 0.
Yes, awesome. So whenever you divide both sides by something, please make sure you know that thing is not 0, okay? So this pops up a lot when you see sine squared equals sine x. Everybody and their mums always divides by sine x. Don't be like them. Be smart. And bring everything to one side and factorize, and then go, okay? Now in this case, I'm allowed to divide both sides by 6 because 6 is not 0. So I'm writing this. In orange here, or blue, I'm writing something that you do not need to write in your exam, but I'm just getting you in the habit of it, of justifying to yourself why you're allowed to divide both sides by stuff. What are you talking about? Huh? No, just kidding. Please fix me on mistakes, because I'm talking a lot, and then my brain's going a million miles here, so I should be better, but let me know if there's mistakes. Okay. Factorize that. Two numbers that add to 1 times the negative 2. 2 and... Thank you. Okay. Have we answered our question? What is it asking us? The equation. So I need to go further, don't I? Now, just real quick, if the question just said, where are the tangents horizontal? Have I answered the question?
Yeah. No,
This tells me the x values where they're horizontal. Usually when they say where, sorry? I want to find the whole point. Like, I just want a complete answer. Now, typically the question would actually just say, find the points where. They won't just say where, okay? But remember that. Okay, now, I want to find the actual equations. So, I'm going to do one of them for you. You're going to do another one. Can you guys try and find the equation of the tangent when x equals negative 2? So for x equals negative 2, find me the equation. And I'll do it for this one, okay? So you have half the work. Find me the equation of the tangent. Equation of tangent? Equation of tangent.
Slow down.
Oh, no worries. I said find me the equation of tangent when x equals negative 2.
Okay.
So, yeah, the question's basically now, I'm giving you that y graph, find the equation of tangent. Okay. Let's see how you guys are doing it. Did you write one? Awesome. Wait, this one?
Yeah.
Oh, sorry. You can, look,
Oh, I already.
you can go ahead. Be my guest. No worries. So, yeah, you got my permission, go ahead. Yes, I love how you just wrote it. Perfect. Wait, don't say that. What are we thinking about? How are we doing this?
I just solved the
Yep.
x value into
Yep.
the original
Good,
equation.
good. And then does that give us the equation?
Oh, that's
It just gives us the
It's just the point?
points.
Yeah. Yeah. What do we usually have to do to find equation of tangent? What are my steps? Yes? So we've got that, and then sub in a point, you've done that. And then this one, right? Yeah. Cool. Okay. How did I just get it? Guys, everyone look up. I know you guys are still trying it. but I'm going to stop you where you're doing right now. Who's got more than like 3 lines of working? Who's got 3 lines of working-ish? Yeah? Look at my one. Do you see I just got it? I just got it 1 line. Huh. But I've given you like 4 steps here-ish. 3 to 4. So you should expect a lot of lines because we've seen it takes a lot of lines to do a usual question. How did I get it in 1 step? Yes?
The gradient is 0, so x minus x1 is already 0.
Good. Okay. Liz just told us that we're eventually plugging it in here, right? Now, Tanishi, I'm so sorry. Tanishi told us that when tangents are horizontal, the gradient is 0. When tangents are horizontal, m is 0, so you plug that in there. Y minus y1 equals, wait, what? This whole thing's gone. Do you see you would just have 1 step? But here's a better way to just think about it. If something's horizontal, then you know it's a horizontal straight line. What do the equations of straight lines look like? Like if I gave you that, and I said this was at the level of like 2. What's the equation? It's just y equals 2. Do you guys see you already know what the shape is? Yeah. So all I really needed was, what is the y value of the curve? And then that's going to be the horizontal tangent. Does that make sense? All right, one more way to explain this, by the way. So let's say I do have some rando cubic. Remember, cubics usually look like roller coasters. They don't always have nice inflection points. So it looks something like that. It's asking for whether tangents are horizontal. Can you roughly see which 2 points make the tangents horizontal? Yeah. Which ones?
The bends.
The little bumps. Now, does everyone know the name we call that?
Inflection points.
No inflection point, because inflection goes like this. What was it? Maximum, minimum? Yeah. So you know like the maximum and minimum point of a parabola? Yeah? Usually we call that a vertex. But when it comes to every other graph, we don't use the word vertex anymore. So there's another word for vertex. That's with a T. Yeah, turning point. So these are like turning points. Or here's a fancy new word for you. Starts with an S. Stationary point. Stationary point. We looked at this, yeah. We'll do this later today as well. So just introducing some language to you. Anyways, at those turning points or stationary points, the question's asking you to find the equations of these 2 black lines. That's what it's asking you to do. So clearly, I just need to find the y value, like where that graph gets up to. So for example, when x equals -2, I'm just plugging it in the y function and getting the y value. I can see the y value is equal to, actually, did anyone, did you get 6, Liz? Because you plugged it in, right? 21? 21? Okay, so it gets up to y equals 21, which means, I'm glad you understand it. That means the horizontal straight line has an equation of y equals 21. And then over here, when I solve x equals 1, that means the equation has the horizontal straight line has an equation of y equals -6. Any questions with that? So whenever it's horizontal, 21. What's the takeaway? When you got horizontal tangents, do you have to do all the steps? What do you just have to do? What's the one thing you do? Find the y value. Good job, Amy. And then that will be your line. Okay, cool. So there's always faster ways to do things, all right? Does anyone need a picture of the board or want a copy? I can give you a little bit of time to finish copying if you want a picture. Because I'm about to rub it off in like 10 seconds. Okay, thank you. Beautiful. Love the sound of that. Okay, now, Shuria, help me out, man. Tell me again what a tangent is. Like, describe to me what your definition of a tangent is.
It's a straight line that touches
A point on the curve. Would anyone have a slightly different definition? I love that one. Come on, we said other stuff. Instead of a point.
You're rubbing out an empty point in the wall.
I was just testing you again. Look, we aim for perfection here, and I noticed there was an atom. See, I know chemistry. There was an atom of marker. So I just keep going. All right. You guys told me earlier that the tangent is a line that touches the graph at how many points? 1 point.
What is that?
1 point, Mira.
Ew.
Mira, 1 point. A tangent is a line that touches the graph at 1 point. That's what you guys said, right? Would you guys agree this black line's a tangent? Yes. Does it touch the graph at one point?
Yes.
Yes or no?
Yeah.
No. Where does it touch again?
The other side.
Dude, extend this. Do you see it's gonna hit the orange one? Oh my God. Ready? So I just want you to fix your definition of a tangent. Tangents, they actually come from circles. So when I draw a circle, like obviously a straight line is only going to touch a circle at one point here. Like if that's the tangent, it's not going to touch the circle again because the circle is like just all underneath. But with curves, they can do weird shit and then they can like pop back up and down. Okay, so a tangent, the definition is actually just always defined at the point they've given you. So like this is the tangent at x equals -2, not like a tangent to the whole curve. So at -2, it just touches. It like bounces off the curve. It touches just once at x equals -2, but it could touch like any other time. Does that make sense? Like afterwards. Because it's just saying at x equals -2, when do you have a straight line that is the same slope as the orange line? Like when are they exactly kind of just meeting each other in their behavior? Okay? So tangents could hit more than once, which is why, don't get confused when you see something like example 4. They told us the tangent to the curve parallel to another line, okay? And then they said find the point where the tangent touches the curve. Actually, I lied for this one. But in example 5, oh, I'm one step ahead. But in example 5, we'll see a question where it's asking you for the point of tangency, where it just bounces off. And it also asks you for the point where it hits it again, okay? But let's do example 4 first. Can someone read out the equation to me?
Y equals to 2x squared minus 3x plus 1.
Thank you. Was that to Nishi?
Yep.
Thank you.
It's parallel to the line L, and then 10x minus 2y minus 1 equals to 0.
Minus 1 equals 0?
Yeah.
Thank you. Okay. It's asking you for where the tangent touches the curve. All right? Where the tangent touches the curve. Let me quickly write in, do I have a red pen? Let me quickly write something that people would try, but is incorrect. Here's the line y equals 2x squared minus 3x plus 1. I can see there's another line here. If I want to find where the line meets the curve, okay, I'll do this. You know what? This is a bit wrong anyway, but here. Okay, there's two things wrong with doing this step. Can anyone tell me? What's something that's wrong with doing this? Liz?
They're not equal.
They're definitely not equal, first of all. When we want to equate curves, the only way you do it is when you've got like y equals something, that's when you let them equal. So basically when you've got all x's on one side, all x's on one side, that's when you equate them. So that's already a big no-no. I don't want that y. Let's say I actually did write this in the form I wanted, where y was the subject. What's wrong with equating this and the line they've given us? It's not the tangent. What is this line? This is like some irrelevant line. It's just some other line that's not on the team, okay? So I've got a parabola here, and then graphically, let me show you what they're telling you. There is an actual tangent which I want, let's say over here. That looks like a good tangent, right? The line they've given you is just a line that's parallel to the tangent. So, no, imagine that's parallel. They just gave you that. So do you see this line would never meet the orange curve anyway? What you're trying to do is use the information about this one to figure that out, okay? So clearly that first step, I do not want to do something like this. In fact, it's so bad, I'm just going to rub it off. This is like monstrosity on my board. Okay, what would I do though? Who can help me out?
Did you find the gradient of the parallel line?
Good. Okay, when something is parallel, okay? Avika, when two lines are parallel, what do you know about their gradients? Yes, so M1 equals M2 when you've got parallel gradients, okay? So like Vincent said, I'm gonna try to make this slope, like the gradient of my parabola here, I'm gonna try and make that equal to the slope of this one, The gradient here, could I say it's 10? No. What should I do first before I look for the gradient from this curve? Well, how should I rearrange it, Mira?
Move the 2y over to the other side.
Perfect.
And divide everything by 2.
Cool. So I'm going to try get the form mx plus b. That's why we teach you all of those things. Like you think it's, you know, just a new formula that you have to learn, but it's like these are structures in your mind that you now know because you've grinded so hard during year 7 to 10. And you now know that mx plus b will give you the gradient right away. So looking at this, I know my gradient should be 5, and it's telling me that the tangent is parallel to this gradient. So therefore, gradient of the tangent, mt, equals 5. All right? mt equals 5. Now, I just replace I'm just going to keep replacing this with what I know. And what I know for gradient of tangent is I know that it's actually represented by the derivative. So I can find the gradient at any value of x. So let me plug that in there. Y dash of x equals 5. And then let me just solve for that. Is that okay? Is this too low for anyone, by the way? I know some of you guys are sitting at the back. Okay, just let me know if you can't see the board. 2x squared minus 3x plus 1, differentiate that, you get 4x minus 3. So 4x minus 3 equals 5. Alrighty. Have I finished my answer? What do I have to do? What do I have to do? Sorry? Y coordinate. I need to find the point. Okay? That. What do I need to do? What do I need to do?
Can you repeat the question, please?
Well, I've got x equals 2. Yeah? Have I finished the question? I need the y value. Okay, listen up. So I want to make sure that my answer looks like 2 comma something. All right? Is it free? Thank you. 2 comma 3. Is anyone working ahead right now? I'm totally fine to work ahead because I told some people to work ahead. Liz, did you get example 5? Bit of a funky one, right? Did you like to solve at the end? Okay, guys, example 5 is a huge question, but steps part A and part B, you can actually do. So I'll get you to start reading it, and then I'll draw up. Actually, I'll do part A for you, and then I'll ask you to do part B for me, okay? All right, so part A. I want to sketch the curve x cubed minus 2x. Guys, every time you see a question like this, or just a sketching curve with a bunch of x's, what should you be thinking to do? Starts with F. Rhymes with factorize. Yeah, it's factorize, okay? So I need you to factorize this. There's a common factor of x, that's great. X squared minus 2. Can I factorize this further? I can. How do I factorize it?
Plus minus root 2.
Good. So this is a difference of 2 squares, although 2 is not an intuitive square number. You can just think of this as x squared, take away square root 2 all squared. Do you guys agree square root 2 squared is just 2? So when you write it like that, you now see a difference of 2 squares that I'm going to break up as a minus b. A is x, b is root 2. And a plus b. Does anyone have any questions with that? All good? Okay. Now, sketch. What I've done here, actually, I'm going to put a little bit of working out that, again, you don't have to do, because you can just read off the x-intercepts. But I'm just going to explain myself. So let y equals 0. And the reason I'm doing that is because I get the x-intercepts. When I let this equal 0, you have 3 brackets equal to 0. So each one of these brackets could equal, they give you a root. Because each one of the brackets could equal 0, yeah? If I have anything times 0, then one of them must be 0, right? Like if I had, 6 times 7 times 0, this is still 0. Does that make sense? Or I could have all of them as 0. So therefore, I could either have x equals 0, x minus root 2 equals 0, or x plus root 2 equals 0. And then solving that, you can see x equals 0, x equals root 2, minus root 2. In your exam, feel free to just go straight to this line and not do each one equals 0. But as you probably saw from one of the questions you did with Calvin on factorials yesterday, you remember there was like an n minus 1 factorial question, and it was like equal m plus 1 factorial plus n factorial. It was like some weirdo question like that. That one, you expand the whole thing, you also get brackets equaling 0. With something more scary like that, I would want you to actually break it into different cases, okay? So just keep in mind of how much working you want to put when you feel like you need the extra support for it. Okay, almost there. I now want to sketch it. Here's how I like to do this. Every time I sketch one of these questions, I ask myself, does it start from top right or bottom right? I do it like this. A lot of other teachers do it in different ways. This is how I do it. So why would it start from top right or bottom right? I like you to think of the most basic curve you know, which is like the parabola, yeah? Or the cubic, either one's fine. A positive parabola, like positive x squared or positive cubic, they always start from like up here, right? Do you see it starts top right? But negative x cubed starts this way. I'm just going back to things you already know. So now I know if the leading coefficient, leading as in the first one, coefficient as in the number in front of x cubed, if it's positive, then it'll match something like a positive cubic. And then if it's negative, then it'll match something like this, where it starts bottom right. So in this case, does it start from the top right or bottom right? Top right. It starts from the top right, because it's positive. So you look at the leading coefficient. This is notes for you. This is not exam working. When I say leading coefficient, you don't need it. Top right. Positive, so top right. Okay, now draw your x-intercepts. And then, yippee. It's like a roller coaster. So what I mean is, draw your x-intercepts of 0, root 2, negative root 2. You're starting from the top right, so I start by drawing that arrow, top right, and then I just go yippee through the little points, okay? It's like a roller coaster. Yippee, yippee, yippee. Are you guys okay with part A? Question? No? Okay. Yeah, that was okay, A-okay. You guys do part B for me, and if you are very fast, you can try starting part C. Do part B, start part C if you can. Who got part C? Like, got it, sort of? Part C's tough. Part C's really tough because the conceptual part is hard, and then the actual solving is difficult as well. So there's 2 hard bits. Okay, let's do the first hard bit. So the first hard bit is actually interpreting a question. The tangent meets the curve at a second point. Do you remember that's what I was showing you here? Like, if I have a tangent, yeah, sure, when I'm here, it's just touching the curve once, but it's going to hit a second time. So that's what it's asking you to do. Does that make sense? Okay, now a tangent. A tangent is really just what? Like, it's a fancy name for a... It's just a line. This is a line, and the line hits another graph. The line's just a graph ultimately, right? So you got graph 1, which is a line. You got graph 2, which is a parabola. How do you figure out when 2 graphs hit each other? You're looking for when 2 curves intersect. You equate them or solve simultaneously. Equating and solving simultaneously is the same thing because you're really just using elimination or substitution when you equate. You probably never thought about that. It's substitution. You're just taking y equals x for something and you're plugging it in the y in the other thing. Is that okay? All right, so tangent meets the curve again. Where's my orange pen? Tangent meets curve again at some second point. So what are we doing? This is just, let me go a little bit like, actually no, I won't do that. Let's do this. Some graph. You think graph 1, graph 2. And then meet is really just intersect. So when you make things intersect, you just solve simultaneously, okay? Can I just get a quick hands up? Who got up to that part of solving simultaneously? Yeah, okay, wait, keep your hands up. Put your hands down, or up. Keep your hands up if you actually solved it. Yeah, okay, so this is the hard part. Now let me solve this. Our graph 1 was x minus 2, right guys? Was that your equation? Yeah, what was my parabola again? X cubed. Minus 2x. It was a cubic, not a parabola. My bad. Okay, now equate them. X minus 2 equals, let me write it like this. X cubed minus 2x equals x minus 2. All right. Let me show you two ways of doing this. The first way, I'm just going to do what you guys probably did, which is take everything to one side. Does that look like what you guys have? Okay. Can I use a quadratic formula on this? Do I have a cubic formula? You can Google it. It's horrible. Don't use it. This is a polynomial. Poly means multiple. There's like really big powers here. So think back to year 10. How do you solve a polynomial? Think back to quadratics. If I gave you this, you don't just solve this, do you? You have to first do what? Reminds of factorize. You have to factorize it. Can you factorize a polynomial? How do we do that? How do you factorize a polynomial? Who learned how to factorize polynomials in year 10? No, year 11? Yeah, who's doing events only, by the way? A few? Okay. For all of you events only people, you actually do not need to know this technique. It's just sometimes in year 10 they've taught it to you. That's why I'm just showing this, okay? So you know what? I'm not even going to continue with this. For those of you who do extension, you are allowed to use extension techniques in advance. Like, I'm actually allowed to do some like ridiculous uni technique in extension 2, even though the uni technique is much better. But what that's doing, it's like bringing a sledgehammer to like a mosquito fight. Like, I just need like a little hand to slap it, not a big thing, right? So sometimes that's overkill. But what you can do for those who do extension is you can factorize this by, remember, looking for factors. Look for factors of 2, and then you do some factor theorem stuff. You can do some polynomial long division or some other things. I can show you later some quick ways to do it, but there's a long way to do it. Okay, we are in an advanced course, so there must be a way to do this using advanced techniques, right? Liz, did you end up solving this using factorizing a polynomial? Okay, let me show you this, guys. This is really important. Guys, look at this. When I solve this, I'm not going to move everything to one side blindly. I'm going to do it like so. X cubed. That x there, I'm going to subtract it, but not combine with this. I'm just going to leave it next to the x. Okay? Look at this negative 2. I'm going to subtract it to the other side, but I'm not going to combine it or like leave it anywhere. I'm just going to leave it. Actually, I guess I'm leaving it. But I'm going to put it here on purpose. Like that. And now I've got this whole thing equals 0. Why do you guys think I've done this? Yeah. You know the first time you ever learned how to factorize non-monic quadratics? It's like you do this thing where you group in pairs, but normally you just deal with that for x squares. You don't think too hard about cubes. You can still do the same thing with cubes. Look at what I have. Do these not have common factors? Yeah? Do these have common factors? Let me group them up together, like so. The negative is a bit awkward here, but I guess I'm kind of grouping this together. Okay, factorize an x. Guys, what do I get? Factorize x, x squared. Beautiful. What about this one? Yeah, nice. This is great. Or normally, when we group in pairs, you just see like instantly you see the same thing and you factorize that out. These aren't the same, but they are related. How does x squared minus 1 relate to x minus 1?
X plus 1, x minus 1.
Very good. There's a common factor in there. So let me factorize this even further. X minus 1, x plus 1 from difference of squares, x minus 1 equals 0. Do you guys see it? What should I do? Yeah? Guys, tell me, what should I do? I should factorize it. I should factorize a common factor. Now I'm left with x plus 1 minus 2. X minus 1. I'll fix the inside up. X squared plus x. take away 2. Is this not something you can do? Who can do it? What is it? Factorize it.
X minus 1, x plus 2.
This is just x minus 1, x plus 2. Now, I've got 3 brackets, and you know you're good with that because we just did it in the other question. And you can actually solve this. What you see are 3 roots. If you have a cubic, expect 3 roots. Sometimes you get less, but expect maximum 3. And in this case, I do. I've got x equals 1, x equals 1, and x equals negative 2. As just a little bit of fun fact, we call this a double root because it happens twice. Nice. But you don't have to, write this in your exam. I just think double roots are cool. Is that interesting? But what we're really looking for is that x equals negative 2. Did the question just say, what was it? Find its coordinates, yeah? Have we done our question? What do we have to do again? Yes, so I'm looking at this. This is where it must meet a second time, because obviously it meets the first time at 1. And I need to write it like negative 2, comma. And in this, you can just use a calculator, okay? So you just plug negative 2 into over here. That's negative 8 minus, who can beat me? Negative 8 plus 4, 12. Is it? Is it minus? Am I tripping? I think it's minus 12. Do you agree it's minus 12? Nice. Yay. Okay, what did you guys learn from this question? You learned to sketch these things. That's important. Did everyone know how to do that already? That's good. I'm happy. You learned to solve tangents again, so you were just practicing that skill. The hard part was part C. So whenever I ask you, hey, tangent meets a curve, what's the step you're going to do? You're going to equate them. You're going to solve them simultaneously. I just want to say something about equating. Now, if I gave you a curve like a circle, who can tell me an equation of a circle? Any equation of any circle?
X squared plus y squared equals 16.
Thank you. Beautiful. So that's like a radius of 4, right? If I have the line y equals 1, actually, let's do y equals 16 to make this funky. And x squared, no, I'll just do 1. X squared plus y squared equals 16. Can you equate this? Like, it just feels weird to equate. You're like, what do I equate? Do I replace 16 with 1? So I just want you to also remember solving simultaneously. Because in this one, I clearly have to actually substitute y in there rather than just equating it. Fair? Now, if I gave you something like a legit curve, like x minus 2, there is nothing to equate. What you want to do is take x minus 2 and sub it into y. All right? So we're going to solve simultaneously. But in this one, when both are y, it looks like equating. So that's good. All right, so after you equate, if you ever get a cubic equation that's really messed up, I want you to remember that for some of you, you've got this super powered tool of polynomials, but unfortunately, it takes a long time and some of you forgot it even. I want you to remember what exam you're sitting. Is this extension 1? What are we sitting? So there must be some way to do it not using the weird polynomials technique that half of you haven't even heard of. What is the way? What did I do here? Let's write it down. Let's give it a name. What's the technique I use, guys? I grouped it in pairs in a smart way. Okay, I grouped it in pairs. Okay, guys. Varun. Now, okay, if I pair them in a not smart way, it would look like this. Why do you think this is a worse way to pair it?
It's harder to see the factors.
Yeah. Okay, so let me just be clear again. I paired x with x cubed and I paired 2 with x. Now, what I could also do is like bring this x and pair it with this guy, and the 2 I can pair it there. But that's not a good pairing, because do you see, it's harder to see factors, and also like, what is the factorization of x cubed plus 2? I can barely do that. So there is a smart way to do it, which is this way, and like a bad way to do it. But group pairs in a smart way. Any questions? If you had to come away today and you couldn't replicate part C for me, that's okay. Remember what Calvin said? You actually have to go home and practice a lot. You probably have to forget this, see it again, get it wrong, probably repeat that process like 3 times until somewhere in year 12, where you've seen it like 5, 6 times and you're like, I got it wrong every time, and now I know. maybe 6 or 7 times. Maybe. You need that extra practice. So if that was the case, then you'd finally get it. But if after today you don't know it, that's so fine. I'm so fine with that, okay? Alrighty. Time check, 11:16. The next little bit of stuff is still part of your syllabus. But I'm going to go for a bit quicker just because it's time, and also these are the main type of questions you'll usually see, right? But I'll go through the next few bits a bit faster. Okay guys, I'm drawing the line y equals x for you. Y equals x. Can you tell me what angle you reckon that acute angle is equal to? What makes you say 45?
Because the gradient's 1.
Yeah.
And tan theta equals 1.
Mm. Nice. That is the thing we're going to do today. We're going to relate the stuff we're doing to tan. Okay? Now, here's just one more little intuitive way to do it. If it's y equals x, then the gradient's 1. A gradient of 1 means I walk 1 step forward and I go 1 step up. Okay? So do you see it's always like 1 to 1, like this? What kind of triangle do you get if it's always 1 to 1? It's a right angle triangle, but also I'm going 1 unit this way, 1 unit up, or 2 units and then 2 unit up. Do you see the side lengths are always equal there? It's an isosceles triangle, and you know, you can do a little bit of trick here, but a little bit of triangle stuff. But if that's 90 degrees and this is an isosceles triangle, are you okay with this guy being 45? Is that okay? Cool. So as you can see, I can relate gradients to angles. I think that makes sense because an angle will tell you how steep something is, and a gradient tells you how steep something is. So that's why we're connecting those two things together. Now here's another line, okay? The angle of inclination here, there are a couple angles you could draw. I'm going to draw this one, an obtuse angle. Now there is also an acute angle that could represent this. Can anyone see it? I could do that, right? The negative angle. We're not going to use that. What we're going to do is we're always going to call the angle of inclination either acute and positive. This is the main thing, it's always positive, or positive obtuse, okay? So if I only have 2 scenarios, a gradient that's positive or a gradient that's negative. Gradient that's positive will have an acute angle, gradient that's negative will have an obtuse angle. Fair enough? The angle we're going to use this symbol, what's that called? Theta. Does anyone know what culture theta is from? What ethnicity? Yeah, it's a Greek word. Greek. Alrighty. So, here's the one big formula you need. You just need this one thing. Gradient of any line is equal to tan of the angle of inclination. Why is that the case? Do you guys see gradient is rise over run? Rise is the x or y value. That's the y value, right? And then run is the x value. Or actually, let me put it like this. The rise, is that the opposite or adjacent side to this triangle? The rise is this guy, that's the opposite side. And then do you see the adjacent side is just the run? Rise over run is opposite on adjacent. Opposite adjacent is equal to 10. That's why that formula works, yeah? Just use that formula though. Okay. I'll show you how to use it in a question. Let's skip example 6. It's a very basic one. Let's just go straight to 7. Okay? Funny, help me out. How do you find x-intercepts? What's the thing I need to do to find an x-intercept? Let y equal 0. Now in this case I've got f of x, but you know y is just f of x anyway, yeah? Okay. Simran, how do you find, tell me what the x-intercepts are here. So I'll let y equal 0, and then the equation, 2x equals 0, because it's just f of x. What should I do here, Simran? Good? Like so? Happy? And can you tell me the x-intercepts? Awesome, amazing. Thank you so much. All right, now I want to find the x-intercepts of a curve, and I want to label them P and Q. So they just want me to call this P, call that Q. All right, part B. Find a gradient and angle of inclination of the curve at P. Wow, what a mouthful. I'm just going to draw this for you. You don't have to draw it, but I'm just trying to show you like what your math is actually doing here. Okay, so this guy has an x-intercept at 0 and an x-intercept at -2. So it looks something like that. It says find the angle of inclination of, it says the tangents, right? Yeah, question?
You do have to do it in part B.
Oh, does it say?
Yeah, sketch the question.
Where? Oh, sorry. Okay. I guess we're just doing a bit ahead. Okay. This is kind of part D. The tangent, would you guys agree? Okay, actually, let me draw you a better curve since we're going to do it properly. My bad. What's that point again? Oh, was it P? Thank you. Appreciate it. If you need extra resources. Thank you, Paul. Okay, so that point there was P, right? This is the tangent at P. Now in blue here, I'm going to draw the tangent at Q, and it looks like this. This is kind of horrible tangent drawing. You deserve better than this. Sorry. Okay, there you go. Okay, that's point Q, okay? Now, I want to find the angle of inclination of the tangent to point Q. So that is the angle of that line. Now, one thing I forgot to stress to you is that this angle is always, it's called the angle of inclination, but it's always measured from, remember these words, positive x-axis. Positive x-axis. You don't measure the angle from like this guy. Do you see that's negative? So you start from the right and you just go up until you hit the line. It should be an acute angle here because we've got a positive gradient. Now, how do you actually find that? Let me give it a particular name. In fact, I'm going to call it theta with a little p under it, okay? So putting that into our formula, I know for part B that the gradient is equal to tan theta. Now, because I'm going to solve for theta, I'm going to write the gradient on the right-hand side, like so. Is everyone okay with that? Tan theta of P equals gradient P. I'm just using that formula. Now, I'm going to sub in everything I know. What do I know from here? Do I know what theta P is? No, I'm trying to find that, right? Tan is just an operation, so I'm not really doing much with that. Do you see I need to find gradient at P? How would I find a gradient at P? Can someone help me out? Sub it in where? What tool would I need to find a gradient of the tangent at P? Yes, it does. Where should I sub it? Kristen, what about you? Where should I sub? Like, what should I do to find a gradient of this line? Guys, what's the topic we're doing today? The topic we're doing today starts with D, rhymes with differentiation. It's differentiation. Remember Calvin says not derive. I need to differentiate the curve.
You're not an English teacher.
No, it's just derive means to prove something. So a lot of people say derive it. Yeah, because you're talking. Differentiate. It's because you guys are interactive. I feel, I either pick on people if I want their attention. All good. Or if they reciprocate energy, or if they're not working hard. Like, there's a few people here who are just grinding away, so I'm not trying to like take them out of the zone. So sometimes I do that and I apologize. Sometimes you go like this and I'll ask you guys for a question and you're like, oh, what? But you guys are just working hard, I know. Okay, now, gradient. I need you to remember, gradient is always the, starts with D, derivative. So please find a derivative for me. Guys, f of x equals x squared plus 2x. F dash x equals 2x plus 2. This is what you're using. Does that make sense? Okay. Guys, help me out. What would you do to find MP? What's the x value to sub in?
Is it 0?
Yeah, this is the gradient at 0. So do you guys agree I just need f dash of 0? This is horrible working out. Let me write it over here so you can see clearly. The point P is 0, so I'm just subbing that into the gradient function. F dash of 0 is equal to 2 times 0 plus 2. Just 2. Okay, after a big bunch of work out on the right-hand side, I've now found our number. So what I'm really doing is solving this equation. Okay, now there is a quick way to do these, and there's a more legit way to do it. I want you to get in good habits of solving trig equations, so I'm going to take the slightly longer way, because usually when you got to solve a trig equation, you have to find related angle or reference angle. Do those two words sound familiar? And you have to find what quadrant it's in, and then you might have multiple solutions. I just want you to use that same blueprint for this one, just because I don't want you doing the actual trig questions and doing shortcuts that you shouldn't do, okay? All right, so first, related angle. That is just the acute angle, positive acute angle that we think will make tan equal 2. Now that's not an exact value, so what should I do in my calculator? I should use tan inverse. Is everyone okay with that? So this must be tan inverse of 2. Now, you can chuck that in and get a number. In fact, is it okay if I just borrow this quickly, Vincent? I love this. He's getting to a real mathematician level. See, his words are rubbed off. My calculator, you literally can't see the numbers because I use it so much. So one day you'll get there. All right, over here, tan inverse of 2. 1.107. Just kidding. 1.107. Do you guys think that's in degrees or radians? Yeah, because degree would be 1 degree. That's kind of small, right? So clearly that's a radian one. I want you to do these questions in radians. Can I get something in your head, guys? If it's calculus, if it's differentiation, radians. If actually everything radians unless the question asks you in degrees. Or unless it's a really real life thing like bearings, okay? So always do radians. Now, whatever that number is, that is my related angle. Now my quadrants, I need you to help me out with this. Remember it's all stations to central. This is positive. What quadrants do I want? Where tan's positive? Yes, good. I want the first or the third. However, look at the fact that this is a positive straight line. The angle could never go all the way there to the third quadrant. Do you see if I took a third quadrant angle, I just keep going for no reason? So what I need you to realize is I only ever want acute obtuse. So really when you're doing quadrants, you don't really need this part. You just want an obtuse angle or an acute angle. And obviously, because it's positive, I'm going for an acute angle. So I want something there, okay? Now I'll just solve. I know this looks silly. Wow, the answer is tan inverse of 2, or 1.07. It looks like I just repeated what I wrote here. I'm just following the steps we usually do. Now also, I'm gonna find the obtuse one, and you'll see it is a little bit different. So for part C, tan theta of Q equals the gradient at Q. Gradient means what? F of x? Does gradient mean f of x? No, gradient means the derivative, right? Gradient means the derivative. So f dash, what? F dash of -2 in this case, okay? F dash of -2. So you're going to plug in -2 into the derivative. That is going to be -4 plus 2. -4 plus 2 is -2. Okay, clearly you'll see something a little bit different here. For my related angle, this is the thing I want you to get in your head, okay? In fact, can you do this for me? You know how we just did tan inverse of the number? Yeah? Can you guys, if you have a calculator, can you type in tan inverse of -2 for me and tell me what you get? Did you guys get -1.107? In terms of degrees, that's probably like -60 degrees. Do I want something that's negative? No, I clearly want positive or acute obtuse. So basically, whenever you just take tan inverse of stuff, you don't always get the right answer. It's really weird. What I want you to remember is, even if that says -2, when you're solving a trig equation, just take tan inverse of the positive number for me. Can we do that? That'll give you the acute angle. Then figure out the -2 bit by actually putting it into the correct quadrant, okay? So for the quadrant, It's either first or second quadrant. And all stations to central tells me first is positive. So I'm looking for a second quadrant answer here. All good? Do you guys see the way I've drawn that? I'll make it a bit bigger over here for those who can't see. The way I've drawn it is like this. Can you see that's clearly just 180 degrees? Am I going backwards or forwards? I'm going backwards, right? Backwards means minus. So 180 minus your acute angle. Is that okay? All right, so therefore, theta p equals 180. But we're doing radians, so what's 180 in radians? Pi minus 10 inverse 2. And then you guys give me what number you get. That would be like 2 point something, right? 2.07 as well? No. Yeah, 2.03. In your own time, you can go and... Good, thank you, appreciate it. In your own time, you can change that to degrees to get a sense of what that is. In fact, if I just... Actually, you can trust me on this. 10 inverse of 2 is roughly about 60 to 70, like unironically 60 to 70 degrees, because 1 radian is about 66. So what this is saying is that graph they gave you, that's about 60 degrees, and then this one's about like 120 degrees, okay? All right, cool. Moving on. Please, I will move on example 8. If there's time, we'll do it. If not, that's okay. I just need you to get the key piece of information. Let's go to example 10 for me. Example 10. Yeah, which is f dash, right? So, can you tell me f dash? That. Come on.
3x minus 6x minus 9.
Or a loss. There's something wrong here. Okay. What do I want for... What's the question say? Increasing or decreasing? Increasing. What do I want for increasing again? Positive. So I'm find x where f dash x is greater than 0. Are we okay with that, guys? Yeah. Shh. Okay, I've got a quadratic here. 3x squared minus 6x minus 9 is positive. What could I do to both sides here to make my life easier? Divide by 3, thank you. X squared minus 2x minus 3. Now, when I divide both sides by 3 here, I don't flip the sign because 3 is positive. So just keep that in mind. All right, now I want to factorize this, okay? X minus
3x plus 1.
Thank you. Thank you. Thank you for locking in. Okay, now, in a red pen, I'm going to draw what you do not do. You don't solve this algebraically like an equation. It is incorrect to go, oh, well, it's usually like this guy's equals 0, so x equals 3. So I'm going to just do, x and 3, and because that says greater, I'll go greater, and then x greater than -1. This is, sorry, I have to graph it. It is incorrect to do it like this, because you see clearly like something bigger than -1 and something bigger than 3 overlaps together. So there's a bit of ambiguity there. It's like, I don't like that. What I would need you to do is remember, always solve quadratic inequalities. Quadratic inequalities. Graphically. Okay? So, this is a quadratic. Clearly, it's not just x. When it's just x, I can like move stuff to the side and solve it algebraically. When it's like this, always draw it. That's why I factorize it like so. I'm going to draw this parabola. I don't need any detail other than the x-intercepts. I don't care about the y values. So, give me 3, give me -1 on your graph. Draw your parabola. Make sure that you are checking whether this one was a negative or positive parabola, because I could totally make this negative and now you have to draw an upside down parabola. Now, you're looking for where this parabola is greater than 0. This is where people make a little mistake here. I want you to think that you are actually sketching y equals the parabola, true? So do you see you're looking for where the y values are greater than 0? Can you tell me where the y values are greater than 0?
Less than -1.
Yes, it is on the left of this and on the right of that. Can everyone see it's the stuff over here? Okay, that's what I want. The question asks for the range of values of x. It doesn't say interval notation. If you know your school only allows and accepts interval notation, then do interval notation, okay? Otherwise, we'll be lazy and we'll do inequality notation. So x is less than -1 or x is greater than 3. Never write and, it's always or, because you can't have something be lower than -1 and also bigger than 3. It's one or the other. Those are the values of x for which it's increasing. Is everyone okay with that? Yeah, so the boys spelled it out perfectly. When something's increasing, you realize, okay, I'm connecting that to f dash bigger than 0. So I need to find a derivative. Then I'm just solving an inequality. Okay, we are going to move on to example 12 because example 11 is just decreasing. So just to check that we can move on, Kiafi, can I pick on you? What do I do when something's decreasing? What's less than 0? Yes, the gradient. Now, another thing for you guys to realize, because a lot of you, as I walked around to talk to you guys, a lot of you kept confusing tangents with like the point, and you kept confusing tangents with a gradient. Actually, a tangent is the entire line, so it's the whole equation of the line. Okay, so a little bit different. But the gradient function derivative, that just gives you the gradient. That's all I want. I want the gradient to be negative for decreasing. So for example 11, f dash less than 0. That's what you're solving. Does that make sense, guys? F dash less than 0. Now, example 12 is what I'm going to do. Was it Rava or Riva? Rava? What a sick name. All right, Rava. For example 12, can you tell me what it means when something is stationary? Awesome. I'm actually like, so the gradient of the tangent is 0. Is like the fancy way to say it. Gradient is 0 is fine as well. Because the gradient of a curve is just f dash. Yeah. We understand that. Beautiful. Okay, so I'm trying to let f dash equal to 0. Does that make sense? Can I get you guys to write this statement in green in the exam? So in exam, you need to write this. Stationary points. Unfortunately, you cannot, teachers don't like abbreviations. So eventually, like, you'll figure out whether your teacher's okay with stat point, because that's usually what I write. You can see that's why I can't spell stationary. But try your best to write the whole thing, unless your teacher says you can abbreviate certain things. So stationary points occur when the derivative, so it might be y dash or f dash depending on the question. But you're just saying when the derivative is 0. Yeah. You have to write that in the exam. Why do you think something like this is useful? Okay, guys, look at the actual graph, right? This is the equation, x cubed minus 6x plus 9x plus 2. Can you guys differentiate this in your heads? Like, you could just do it without writing it down. Okay, so I'm going to do it really quickly. Do you guys agree this is what you get? Guys, get rid of the exam writing that I asked you to write. If I just gave you the thing in black and you just read it, would you, like, as a solution, you're doing a past paper, would you understand what it's trying to say? Yeah, it's like, where did that come from? Guys, remember, spell it out for your marker. As much as your marker likes just seeing the answer at the bottom, they need to see that, like, it's not just random math out of nowhere. So do it structured, and when I say structured, also put headings when you can. Tell the marker what the hell you just did here. Does that make sense? A slightly better thing to do would be to just go, okay, f dash x is equal to, actually I did do that. See, I wrote that here in green, and then I replaced it. Okay, so now, so long story short, green, you're gonna write that in your exam, okay? And it's not just me, like, I'm not just saying be nice to your marker, like, literally teachers go like, if you don't put this, I'm not giving you a mark. Question?
That also applies, like, if it's asking if it's increasing or decreasing.
That one you can go, let f dash be greater than 0. Like, as long as you make some note of what it is, but for this particular one, because this question pops up so much in year 12, like, every exam you ever do, guaranteed, mum's soul, on your soul, it's gonna be in there, on everything Mira owns. Like, it's gonna be in your HSC. That's how, how else can I stress to you that it's important? Because it pops up so much, the teachers have a very specific way of marking it, and it's writing that, okay? For increasing, it's like, they don't pop up that much, so f dash graded. Look, for increasing ones, the teacher's happy that the page isn't blank. Like, a lot of students will just leave it blank. But what I'm doing here is just better. Do you see what I mean? Okay. Let's solve this quickly. Does the question ask for stationary points? Okay, because it's a point, what do I have to do? Yeah, okay, now don't do this. Y equals blah, 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 comma, blah, blah, blah. Do you see, even though I can tell, it's just annoying for me to go, wait, was 3 for this point or was 1 for that point? So, write your answer like this. Is that fair enough? You guys can figure it out. I won't do it over here. Some y value, some y value. Liz, have you finished all the questions? Did you do example 14? Because that's a tough one. TS tough. I'll give you an answer in a second. It's like k between -1 and 1. Yeah, crazy, right? There's a little bit called rates of change, which is like word problems. We didn't get time to fit in this holiday course. Okay, guys, everyone look up. This is really different. This question says, show f of x is always increasing. This question said, find when it's increasing. So this is saying for some chunk of the graph, like for certain parts of it. Oh, sorry. So let's say this, let's just go with this one with increasing as well. This is just saying for some parts of it's increasing, tell me where it is increasing. That question, if it's decreasing, thank you, is telling me, figure out that it's always decreasing. Show me it's always decreasing. So there's a difference. This question was to solve where this inequality. This question is to prove that f dash x is always negative. There's a little bit of difference there. Can you see? Yeah, I'm not like solving this inequality. I just need to figure out that that's always going to be negative. So you're going to see in my working out, I don't actually have a left-hand side, right-hand side that I'm solving. Okay, look at this. To show that something's always decreasing, derivative is less than 0, I'm going to differentiate this, all right? Now, help me out, and I'm going to do this as like kind of separate working out before I do the thing. In order to differentiate this, x to the 5 is really easy to diff. That's harder to diff. How would you... Did you hear what she said? Come on. X to the 5, I can diff. 1 on x to the 5, I should rewrite that as, and this is Tassini. No? Tanishi. I keep rhyming it with Tahini. Sorry. Tanishi told us that I should write it as x to the -5. Is that okay? Cool. So, differentiate this now. F dash would be, yep, good. Okay, awesome. Now, I want to show that this is always decreasing. So what you're trying to do is show that this is always negative. Can anyone convince me that this is always negative? Yeah? What argument would you make to tell me this is always negative? Unfortunately, when the leading coefficient is negative, I could have something like negative x squared plus 100. Obviously, there are some values where this is positive. I could, but I want to make sure it's true for all values of x. Amazing. Now, this might be what you mean by, this might be what you mean by that. Lock in. This might be what you meant by leading coefficient, I'm not sure. But what Liz, everyone. What Liz just said is factorize negative. This is negative of some number. If this is always going to be negative, then the inside should be, if this whole thing's negative, this whole thing should be positive, right? How can you tell me that this is always positive? Hint, look at the powers. Even. Remember we did that in binomials as well yesterday for extension 1? Like, if you have an even power of something, it's always going to be a positive number, right? So what you can say is, that is always less than 0, since x to the 6 and x to the 4 are positive. Tell me why they're positive, as they are even powers. Do you guys see this is a different level of question? It's like you have to actually make an argument for it. You have to interpret that the question is asking you to prove something, and you have to make an argument for it. So I did not solve anything. I just showed that this is always a negative number. How do we feel about that? Any questions? Nope. You understand the difference between these two? Cool. Skipping example 14, if you would like, I can show you during the break. I am just egregiously running out of time. But also, there's not that much left, so we're good. Okay, guys, I've got 3 special points here. Look at that first one. The gradient is equal to what here? So it's called starts with S? Stationary point. Okay, this is also a stationary point. That is also a stationary point. You 3 are all people, but you have different names, right? I want to give these different names, okay? So this stationary point, to give it some importance, this guy is what we call a maximum stationary point. Now you can call it maximum turning point as well. Sorry, what were you guys saying? Did you have a different name for it? Oh, okay, go, next one. Minimum stationary point. Okay, someone from this side of the room. Someone from this side of the room. What do you think I call this one? This side of the room. Anyone? Yeah. Guys, in a cubic, does that look like the thing you get in y equals x cubed? Yeah? What do we call that? Starts with an I. Point of inflection. Good job. Okay, now, special name for you guys. It's not just any point of inflection. It is a horizontal point of inflection. Okay? Were you about to say that? Sorry. Stole your thunder. Horizontal point of inflection. Now guys, if you had to give this an abbreviation, what would you want to call this? You'd want to call it POI, right? What's something else that stands for POI in maths? Point of intersection. So teachers don't like you abbreviating that. Yeah? Just don't abbreviate anything. Now, the reason I call that a horizontal point of inflection is because there's a fancy thing called concavity. Has everyone heard of that before? Yeah? What is concavity? Concavity is really just, am I sad face or am I happy face? Okay? That's all concavity is. So this is a concave up parabola, we usually call it happy face parabola, and that's a concave down parabola. Do you guys see my roller coaster? There are sections of this where it's happy. Oh, that's sad, isn't it? When is it happy? Yay! And this guy, it's like some adrenaline freak, like they're happy when it goes down. So happy, sad, happy. Now also here, look there, look there. Is that happy or sad? This is a sad face. Do you guys see that? Yeah. This is a happy face. A point of inflection is where concavity changes. Do you see we freaking changed mood here? We went from sad to happy. That's why it's called a point of inflection. Just like how a stationary point is actually where you change from increasing to decreasing. Decreasing to increasing. So it's when stuff changes. So a point of inflection is when you change from sad to happy. Everyone okay with that? There is actually another point of inflection on this graph. Can anyone see it? When is the other point on this graph where I go from sad to happy? Right there. Maybe the origin somewhere around there, I'm not too sure. Yeah, but roughly there. Do you see that's also a point of inflection? Do you see why I should call this one a horizontal one now? Is that one horizontal? It's like wonky, right? But we just call that a point of inflection. And then the flat ones we're looking for, the actual stationary points, we call that horizontal. Do you have to worry about points of inflection? Not until year 12. Check your syllabus, okay? That's in year 12. You can, the schools do anything in different orders, yeah?
What's a critical point then?
Critical point is a very vague term for a lot of different things. Like for example, when I'm solving an inequality, I could solve it graphically or through critical points. And for that context, a critical point would be where my graph is hitting 0. Do you see 0 is the thing that separates positive and negative, which is important for inequalities. So for that context, those points are important there, so we call them critical points. Sometimes when we sketch stuff like this, some people call that a critical point. But that's the same as me going, oh, these are all points. These are all stationary points. It's just too vague. Yeah, good question though. Okay. The one question I want to do with you is actually classifying these. Can we please? I'm just going to do one with you. Can we please do example 16 and I will let you go on break. All right. hold me accountable. I reckon, are you okay if I talk through most of this one? Yeah. I reckon I can do it in 3 minutes if I don't let you out by like, let's say 12:05, like kill me or something, okay? Hey, why was there so much agreement in that? Can you what? That? Be my guest. Let me give it to you. Oh, not that one.
Rubbing it out.
Oh, appreciate it. You keep me accountable. Okay, Mira. No, just kidding. We've got the curve. Guys, everyone just lock in and listen. You can just watch me and then you can write it down later. F of x is equal to this function, example 16, x cubed, take away 6x squared plus 12x minus 3. Part A says find f dash. So we're just going to differentiate that as usual. We've seen this before, by the way. F double dash. This is where I'll ask you, what is f double dash? What do you think? If one dash is differentiated once, 2 dashes is differentiated twice, okay? So don't go here and differentiate it twice, like you already did it once. Differentiate this one more time.
It's minus 12x. Yeah.
Thank you. I'm concave up right now. Okay, part B, show that C has a stationary point. So basically, do you remember we did this already in the other question? I should have just combined the two questions. What's the thing you write in the exam? Starts with S. Stationary points are, or occur.
F dash x is
Yeah,
equal to 0.
sorry, I abbreviated points. Occur when f dash x equals 0. So you're gonna go and solve this 3x squared minus 12x plus 12. You're gonna solve it and you'll see that, actually there should be 2 solutions, shouldn't there? Oh, never mind. Guys, quadratics usually have 2 solutions, but this guy factorizes into what? That's a perfect square, isn't it? X minus 2 all squared. If you didn't see that, just factorize it usual and you'll see x minus 2, x minus 2. I only have one solution for this, okay? This is actually my question. This one gives me a hint to find a y-coordinate as well. But basically, I've shown that there's a stationary point at x equals 2. I found it, okay? To finish it off, let's give it a coordinate. But I'm lazy, so just make sure you write your answer like that. Is everyone okay with y value? Just sub it back in. Alrighty, part C. Now I want you to tell me the nature of the stationary point. Remember we gave it different names? The different names are the nature of it. I'm going to show you 2 ways. One way is like messed up. The other way is a lot quicker, but there are pros and cons to each one. Method 1 to determine nature is you use a table. Okay, so draw up a table for me, like so. X, f dash. 2, and then 2 columns like this. Then, method 2, second diff. Okay, oh no, I have 1 minute until I die. Uh-oh, maybe I'll extend my life a little bit. With your table, here's what you're going to do. You're going to sub in values that are slightly on the left of 2, slightly on the right of 2. You're just trying to see what the hell happens at 2, okay? You're trying to see that behavior. All right, chill out. All right, so what's something on the left of 2 that would be nice to plug in? 1, but also a better number would be 0, because it's just easy. That one, just do 3, okay? Don't go crazy. Plug that in. Plug that into f dash. Someone use their calculator, plug in 3 into this first bit for me. Sub in 3 in there. Or actually you can sub it, no, yeah, sub it in there. I'll sub in 0, so 0 means 0 minus 0 plus 12, which is just 12.
Is the 3
Is it 3? Okay. 3 minus 2 is 1 times 3. Bingo, bango. Okay, next bit. That one there, when I sub in 2, you don't actually have to sub it in. You just know it's 0, because you know it's a stationary point, so you know the gradient should be 0. Now, I want you to do this for me. This is really important. When you get these things, this is actually finding the derivative. Derivative tells you what? Starts with G? Gradient. It's a gradient. Can you draw like any line that has a gradient of 12? What would it roughly look like? It look like this, right? I don't care about steepness. I just want like whether it's positive or negative. But beautiful, nice. Okay, draw this. Draw a little bit. Yeah, just draw like that. Now that is 0, so it looks flat. And then this one? Wait a second, it's positive. What kind of stationary point is this? Yes, because do you see, it would go like a little, like kind of bucket if it was a maximum, and it would be like a little trapezium that's going down if it's minimum, and if it's like this one, it's a point of inflection. Okay, good job, guys. Therefore, just from this working out, I can see 2 comma whatever is a horizontal point of inflection. Okay, let me show you the cracked method, okay? It's cracked. When we're happy face, actually sorry, we're sad. When we're sad face versus happy, what you'll see is the second derivative value changes. Sad face, I'm feeling negative emotions. Y double dash is negative, okay? Happy face, I'm feeling positive emotions. Y double dash is positive. That's the rule. When you have a point of inflection, do you guys agree? I showed you this was roughly a point of inflection, and then that one we went from happy to sad. That's also a point of inflection. You're going in between positive, and when it's concave down, is it negative or positive? Concave down, I'm feeling down, it's negative. Negative emotions, negative, happy. You're going from positive to negative, positive to negative. What should be in between? 0. 0. Are we okay with that? Okay, cool. So here are the rules for you. In terms of the nature, I don't think I have to write the rule for the table. You always write a table like this, and then you just look at this to figure out what nature it is. For second derivative tests, and this is just a rule, so you don't have to write this red bit in exam, but if f double dash x of your stationary point, so I'm going to sub in, let's say, x of like p being a stationary point. I'll just call it s. If that is positive, then you're happy. If it's negative, then I'm feeling sad. And then if it's 0, then that's a different story. But can you look at these two for me? If it's positive, I'm feeling happy. Do you think this is a minimum or maximum point? Clearly it's a minimum, just from my happy face, right? When it's negative, this is a maximum point. Does that make sense? That's how you determine nature. And then when it's this one, when it's 0, what do you think? Horizontal point of inflection, okay? Horizontal point of inflection. Kristen, do you have a question? You have to really go? Go. Okay, what I'm gonna do, guys, ready? F double dash, what's the x value I'm subbing in? What's the x value I'm trying to look at? It's 2, right? Sub in 2. What do you get when you substitute 2 into F double dash? 6 times 2 minus 12? Which one is it? It's the third one, yeah? Don't write it like that, but it's that, okay? Do you guys like second method that's cracked? Yeah. Pretty cool, right?